Hi, this video discusses the continuous availability features in EsgynDB. EsgynDB focuses more on continuous availability than your normal big data product because our product targets businesses that serve customers 24/7, where everyone expects 100% availability. Also, due to its scale, big data means more moving parts and therefore more failures. Finally, it's our experience that operational workloads require low impact and fast recovery failure handling. We've designed EsgynDB to handle failures at all levels, from human errors and component failures to full cluster failures and even data center outages. This demo shows you how server failures are handled by EsgynDB. Imagine that we work for Acme Utilities. We sell smart devices for smart cities. We're running an e-commerce application processing sales and returns, running business reports, and doing ad hoc data analysis. The application is critical to our business, so it needs to be available at all times, and we cannot afford any drop in response times. We have a 4-node cluster running EsgynDB. We've taken care to ensure that we have headroom on each node in the cluster. Here you can see that the nodes are using around 80% of the resources. Next, a server failure occurs and we lose a node. The remaining 3 nodes will take over the work from the failed node, increasing resource usage. This is shown as 90% here in the slide. Acme Utilities end users are not aware that any issues exist. The response times are as before and the system continues to function normally. A system administrator is alerted to the issue and repairs the failed server. The server is then reinstated into the cluster, services are restarted, and the cluster rebalances itself automatically, returning the resource usage to the normal levels, that is about 80%. This is what it looks like in real life. The application dashboard shows that our e-commerce business is in full swing. Data about sales and returns are arriving, and you can see that the scheduled reports are running and we're running database maintenance. Here, you can see that I'm killing one of the nodes by rebooting the server, a simulation if you will. As you can see, EsgynDB Manager shows us that we have a partial outage. The EsgynDB components running in the failed node are gone. Let's take a look at what's happening with the application. You see little to no impact since we ensured that our cluster has enough resources to shield the customers from error situations such as this. This means that our business is operating as it did before the failure. All service level agreements are met and we're processing sales and returns as if nothing has happened. This is what we want. At this point, the system administrator gets involved to fix the problem and recovers the services. Let me fast forward that part for you. First, we restart the Hadoop services using the Distribution Manager tool. Then, the EsgynDB components are restarted using the SQShell utility. And finally, we check in EsgynDB Manager that all components have been recovered. In the background, HBase rebalances the data after the recovery, which can be seen here. And note how the number of regions on the recovered node is 0. After some time, the regions have been rebalanced and we're back to an optimal configuration. EsgynDB brings operational thinking to big data. Therefore, we worry a lot about continuous availability. In this video, I showed you how a server failure is invisible to end users. I then recovered the failed server, restarted the Hadoop and EsgynDB services. The data was rebalanced and the system returned back to an optimal configuration, allowing us to handle new failures should they occur in the future. I hope that you've enjoyed this video and found it useful. Please visit us at esgyn.com for more information about EsgynDB. Thank you.